Hello all. Hope everybody is able to hear my voice clearly. Please confirm. Prithvi, can you please also check your audio once?
Yeah, Bhavya, I'm able to hear you. Can you confirm the same from your side?
Yes, yes. A slight echo is there, Prithvi. Slight.
Okay, just
Now,
a minute.
yeah, now it's fine. Thank you.
Okay, yeah.
Right. Yes, Shiva Balan, you have any question? Okay. Before we start on with the session, thank you guys. Thank you for joining us on our second day. A very good evening to everybody. As in yesterday's session, we have discussed about what is VLSI and what is front-end and back-end VLSI, how the career would be in VLSI, and what are the different terminologies that we look into it, and a simple classic difference of embedded and VLSI, all those things that we have discussed in yesterday's session. So today we're going to see the next part of VLSI as in part of it. Um, we have seen your valuable feedbacks, wherein we have seen and considered your points regarding the terminologies, are the speed or your respective positive feedback about the training, and it was very encouraging to our team guys. Thank you so much for your valuable feedback. Hope we continue the same with the next 4-day session also. Prithvi, I think we can start ahead. Meanwhile, you can share your screen.
Yeah, sure. Just give me a moment.
No problem. No problem.
Yeah, hope everyone is able to see the screen. Can you guys confirm the same?
Yes, yes, we can see your screen. Are you
Yeah,
going
yeah.
to put it on?
Yeah, sure. I'll. Okay. So, guys, welcome to day two of Silicon Symphony. So, here before proceeding further on our discussion, like few people yesterday I have gone through the comment section, like many of you were asking about like few things, learn what is the difference between VLSI and embedded systems, right? What is the practical difference between VLSI and embedded systems? So how to choose career path into VLSI or into embedded systems? That's a big question, not just you. In fact, many of the electronics or electrical guys have this particular doubt. Yeah. So let us see on just a minute. Okay. So let us see like what is the difference between our VLSI and embedded systems. Okay. So see, basically VLSI is all about making an IC. Okay. It is all about making an IC. It means that uh, a chip alone cannot work, right? For example, if I made a chip, assume that I have made a chip. And can this chip alone work on itself? No, right? It cannot work. Chip alone cannot work on its own. It needs something like, it needs some power for working, right? It means that it needs some system around it to work. Basically, your chip needs some system around it to work. So whatever the system that you are building around the chip is your embedded systems. Okay, so if at all the chip becomes a system, I mean, if at all you want to make a chip to be part of a system, what you need to do? You need to make sure that your chip is part of a PCB. You need to uh, take this chip and embed this into a PCB along with many other things into it, right? So here, with respect to this, VLSI is not bothered on how you want to use this chip. Okay, where you are going to use this chip or how you are going to use this chip, VLSI engineer is not going to bother about. The only concern the VLSI engineer is having about is how to make a chip, how you want to make a chip. Okay, the main goal is to make a chip. Embedded guy is the one who is going to think on how he wants to use the chip. Okay, so in embedded systems we use these particular ICs to make an application which are specific to a wide variety of things. Okay, for example, with respect to VLSI there are few ICs. Okay, like which would work in power modes, like there are few specific ICs that will only generate 5 volts. Means what is this? This is an IC which is specific to a application. These are known as application specific ICs. Okay, means they are designed only to give you an output of 5 volts. So this is application specific IC. You can use this IC into your embedded systems. Okay, you can use this. So the VLSA builds these application specific ICs are some general purpose ICs. So we will make these ICs. Okay, and for example, if we see a Raspberry Pi 3. Okay, I hope some of you might have heard about this, listened about this word, or you might have used this Raspberry Pi 3 board in your real time, in your day-to-day life. So, what does this Raspberry Pi 3 board typically contains? It will contain a microprocessor. Yeah, who and then what it will have? It will have some Ethernet chip into this Ethernet IC, and then some Ethernet jack, some USB ports, some JTAG ports, or some LAN cable, many other things it will have. So if you see this Raspberry Pi 3 board, what you have here? A microprocessor. Okay, it means that microprocessor was brought and placed into your Raspberry Pi 3, and a Ethernet IC was placed into this. Okay, it means that you are connecting all these things into a PCB. So that is making an embedded systems. Okay, that is making embedded systems. To be specific, to make these ICs into a useful product, so that it can be sold outside into the market, or to interfere with the outside world, or to communicate with another physical system. What we need is a PCB. Microprocessor alone is not enough. The chip alone is not enough. Yeah, it needs to connect to the external world. How? That can be done by using some PCBs, right? So there should be something that needs to be built around it. If at all it needs to be used, whatever the building thing that you are doing, that is embedded systems. Okay, and moreover, in embedded, if it is VLSI, in VLSI what you do is we will do gate level simulations, we will do simulations. What do I mean by simulation? For example, in VLSI you can program your individual mass transistor gates. Okay, the same thing is not possible in embedded systems. In embedded systems, you will take the microprocessor and you will use it as per your need. Okay, for example, if you take ARIA 10, okay, which is a SoC. Basically SoC stands for system on chip. Okay, ARIA 10 is an SoC which is developed by Altera. Okay, so if you want to use this guy, okay, for example, you are using this, you have embedded this onto a PCB, but what you have done is you have given a 15 volts of power supply to this, but ARIA 10 SoC works for 10 volts only. As a result, what happens? You are blowing up your microprocessor, you are blowing up your SoC, the chip is blown. The typical cost of this ARIA 10 SoC is 1.8 lakhs. It goes in vain. So it means that the skill set, so here the ARIA 10 SoC is prepared by a VLSI guy. Okay, the ARIA 10 SoC or the chip is being prepared by a VLSI guy, but it is being used into some practical application by embedded guy. So the skill set required to an embedded guy and uh, VLSI guy is quite different, because here, as an embedded guy, you need to know your skill set is different. Okay, you need to know on how to integrate the things around you. Okay, if at all you are a guy who is interested in system level things, or if at all you are interested in uh, product development, then embedded systems is a future for you. Or if at all you are interested in how to make the processors, how to make processing units, or how to make CPU, so then VLS is a future for you. Okay, so this is what a basic difference between your embedded systems and VLSA. Or in your academics you might have learned mathematics, right? Like mathematical methods, M1, M2, M3. There are many subjects you might have learned, but the basic, I mean, engineering is nothing but application of mathematics plus physics. That's quite basic, right? It is application of what? Physics plus mathematics. A real engineer is the one who realizes that mathematics is everywhere within our real time world. Okay, for example, if you see signals and systems, that's where your Laplace transforms, Fourier transforms, DFT, all these things will be coming into the picture. But as a whole, if you see, you will not see mathematics as the core thing, but you will see your subject. Okay, so mathematics is a backend guy who is working at backend, but engineering is something, or your product is something that is shown at high level. But within that, if you go and see what is there, mathematics is there. Similarly, here also, what you see on the top is a embedded systems. But if you go deep into the embedded systems, what is there? A microprocessor is there. Many ICs were there. So basically, what does this embedded guy will do? He is working on integrating these things. He is working on making sure that these things will communicate with each other in order to make sure that a product comes out of it. Okay, so that is a basic difference between the embedded systems as well as VLSI. Okay, now so let us see on what is the significance of VLSI in today's world. So any VLSI design, if you see, it basically deals with three major things. One is the size of the circuit, and then the functionality, that is the speed, and then energy. And one more optional parameter is the cost of the device. Okay, so the basic question comes is VLSI really a promising field to be pursued? Yes, it is really a very good field to be pursued. See, in fact, this is a very quite good and high-paying industry, and as we have discussed yesterday, it is highly immune to automation. And here, uh, we are designing many great SoCs. Even if you see your mobile phones, basically they are all coming equipped with SoCs into them. Most of these flagship mobiles, whatever the flagship mobile you see, all those flagship mobiles are getting embedded with SoC. Who is making this SoC? Who is the brain behind it? It's the VLSI engineer. Okay, now let us see on what are the evolutions of VLSI, or how does this VLSI came into existence and all these things. So as we all know, like evolution started from SSI, MSI, LSI, and VLSI. So SSI started early in 1950s, which typically has some 1 to 100 logic gates. Okay, and then something like MSI came into the picture. Within this MSI, we started developing few logic functions. Okay, the basic logic functions we started developing, and also some counters, encoders, decoders, all such things were developed in form of IC in this MSI era. Then LSI came into the picture. That is where we have seen our first microprocessor. Then the real life thing came into the picture. That is VLSI, which stands for very large scale integration. This is where we are dealing with millions of transistors. Millions of transistors are being fabricated on a single tiny space of silicon. Okay, so yesterday we have seen like what are the different what phases of design life cycle, like what is back end, what is front end. So let us slightly deep dive more into the design cycle of VLSI. Okay, so see here, as we have discussed yesterday, right, there are two things on a VLSI design cycle, that is front end and back end. If you see here, initially what did we do? We will be having some specification. What was our yesterday specification? We want to make a full adder. Okay, so for that we will be having some specifications. Then what we will be doing? We will be coming up with some micro level architecture. Then what we will be doing? We will be writing some code into that. The code by using what? We will be writing the code using any one of the HDLs. What are the HDLs available for us? It is Verilog as well as VHDL. Once coding is done, we need to make sure that this code is working perfectly. It is bug free. For that purpose, what you have to do? You have to do verification, simulation, and verification. Okay. Once this is done, then we will be doing something known as synthesis. Once synthesis is done, then we will be going to DFT. So what is synthesis here? Synthesis is nothing but converting the given hardware into its equivalent gate level netlist. Okay. So here basic question comes to many people is, for example, I want to have a full adder. So the same code of a full adder can even be written by using C language, right? So what is so special about HDL then? Hmm? So the basic question is, what is the difference between all our existing traditional programming languages and the HDLs? The basic difference is the synthesis. Okay. Whatever the language that you take or that you have heard across, that cannot be synthesized. Okay. That cannot be synthesized. No other language can be synthesized except HDL languages. HDLs are the only ones which can be synthesized. What is synthesis? Synthesis is nothing but converting the given logic or whatever the code that you have written, converting that code into its equivalent gate level netlist. Means whatever the code that you have written, that code is in fact converted into its equivalent logic gates, like how many AND gates are there, how many OR gates are there. So it will be converted into that. The HDL is the only language which has that ability. Okay. So whatever we have done so far, all this thing falls under front end. Once you are done with this, then we will be going into something known as back end. Our back end is also known as physical design. Okay. Backend is also known as physical design. So in backend we have many other things, like uh, timing design is also known as static timing analysis. This is where you have to make sure that everything is happening as per your timing requirements, and there are no any timing violations. All such things you have to take care. And other thing comes into the picture is floor planning, like how you want to organize your chip, like which module you want to place it which place. For example, assume that there is one block, and this block is using clock very extensively, but the clock is supplied by the external environment. So the clock might be traveling something like this. Okay. It Because there are many layers into your IC, clock cannot outrightly travel in a straightforward manner, right? So it travels in a zigzag fashion and it is reaching this boundary. So what is the problem with this? The problem is that the charge has to flow through the metal. If the charge is flowing, it means that it is building up some capacitance around it. The moment capacitance builds, it increases the heat. The moment heat increases, the power consumption increases, which will eventually result in failure of the chip. That should not happen. Then what you have to do? The simple fix is that remove this guy from here and keep it here. So you have to place it accordingly, right? So all such things will be taken care in your floor planning, placement, and routing. And then what you will do is something known as clock tree synthesis. Then we will be doing some checks at our end, like design rule checks and layout versus schematic checks, electric rule checks. All these things will be taking care. And we will be once we are done with this, then we will be preparing one file known as GDS. We will be preparing this
Sorry,
GDS file.
sorry, Prithvi.
Yeah.
Can you make the screen on
Yeah, yeah,
Prithvi?
yeah.
Can you present the screen? Most of the terminology is blur, so people are not able to see it.
Oh, okay. Okay.
Now it's, yeah, now it's fine. Thank
Okay.
you.
So we will make a GDS file, and this GDS file is eventually sent to the fabrication unit. Okay. So this is how a typical design flow of VLSI looks.
Sorry, Prithvi, sorry to interrupt.
Yeah.
Can you just repeat all the backend ones
Yeah.
because they want to make a note of the term on the screen. It's actually blur.
Okay. Yeah. Just give me a moment. Okay. So yeah, first thing is the data preparation. Then it is timing design. Okay. And then what we have discussed is the floor planning. And then it is power planning. like there is some kind of verification that is known as power aware verification, PAV. So all such things will be taken care at this level. And then placement and designing. Then there is something known as CTS, which stands for clock tree synthesis. So basically in clock tree synthesis, what you will do is see, for example, I have few flops like this, flip flops. So our expectation is that, for example, if I give a clock here at a nanoseconds, so our expectation is that my clock will reach all the flops at the same time, but that is not the real time scenario. Okay, so what will happen is, here the clock might be reaching at 0.00001 nanoseconds, here the clock might be reaching at 0.00001 nanoseconds. It means that there is a deviation of clock reaching. So all such things will be handled here in clock tree synthesis. Then one more step comes is routing. Then what we will have is some design rule checks, or layout versus schematic checks, or some electric rule checks. So all these checks will be performed. Once we are done with all these checks, what we will do is something known as integrity checks. Like, there are different modules within a chip, right? There are different modules. So we will basically check whether all this integrity is happening properly or not. So such thing can be tested. Once we are done with all these things, then we will prepare a file known as GDS, and then we will be sending this GDS to the tape out, that is the fabrication unit. So this is how typically the design flow of what we have seen yesterday looks. And here if you see, there are two things here: technology independence and technology dependence. So what is this? See here, can anyone tell, like, what is the current technological node? What is the current technological node the industry is working at? See, yeah, 3 nanometer. That is pretty good answer. Okay, so you might have seen your mobile phones. They are coming with something like, Qualcomm Snapdragon. They will have some specification over it, like, 5 nanometer design, 7 nanometer, 3 nanometer. What is this? This is the current technological node. Okay, so assume that Intel has prepared its first microprocessor in something around 1970s. In 1970s, Intel has come up with its first microprocessor. So in order to bring up this first microprocessor, they might have put lot of resources into it. Many huge number of resources are put, like, they could be human resources, it could be cost, it could be time. Yeah, so they brought up some first microprocessor into the world, and assume that it was designed something at 5000 nanometer. Okay, the first microprocessor of Intel is 4004. Later what they have done, they want to do some enhancements, and they want to release 8008, and they want to release it at something around 1000 nanometer. Let us assume they want to design it at 1000 nanometer. It means that, should they start everything from scratch? Is it required for them to do everything from scratch? Because they have spent years together to write the code, to verify it, to test it, to do lot other things. Means, if at all they want to do some new design into the picture, should they start everything from scratch? It is not required. Okay, whatever the code that they have used for 5000 nanometers, the same RTL code, or the same HDL code can be used even for 1000 nanometer. It can even be used for 5 nanometer. It can even be used for 3 nanometer. It means that these things like specifications, architecture, RTL design and simulation are technology independent. Okay, whatever the design that the earliest microprocessor is used to have, the same design can even be used onto your 3 nanometer chip also. So these things are technology independent, whereas the synthesis and DFT, they are technology dependent. Means, the moment you are moving from 3 nanometer to 1 nanometer, everything changes. All these things will change. It means that the moment there is some advancement in the technological node, the requirement for engineer grows. Okay, that is how the VLS industry is what booming so much. Like, the requirement of engineers is popping up day by day, like anything. Okay, just a moment. I'm not able to move forward. Don't know why. Yeah. Oh, see, these are like, different applications of our VLSI. Like it can be used in smart TV, digital fitness, smart cities. Okay, these are all quite known examples to you on what are the typical applications where we could use our VLSI. And let us discuss about this ecosystem of semiconductors. Like what is the ecosystem? How does semiconductors work? Like right from scratch to the end product. Okay, right from scratch to the end product. For example, you are the consumer and you want to buy something. So from where will you buy these things? Obviously, you will be buying this from one of the retail chains or some via some operators like Flipkart, Amazon, Walmart, or whatsoever. But from where does these guys get their equipments? They will get it from OEM. OEM stands for original equipment manufacturers. So they will go to original equipment manufacturers and they will get these things. Who are those original equipment manufacturers? Like BMW, Apple, or Lexus. Some guys were there, right? So these are the original equipment manufacturers. For example, if you see, if you take an example of a Range Rover, I myself have worked for a Evoque 3 model of a Range Rover. Okay, uh, which is basically for i3C. So if you see these original equipment manufacturers, can they do everything on their own? No, no. This for example, this Range Rover guy, he needs a microprocessor. So can he design it on his own? No. What he will do? He will go and approach some intermediate guys like SoC manufacturers like NXP, Qualcomm, AMD, or Nvidia, or some ST Microelectronics. So they will go and approach some other guy. So what they will do? They will give the required tech to them. Okay, they will give the required tech to them. One of my friend, he is currently working for Intel, and his main focus is on automation, which is the end product is going to be used in Lexus cars. Okay, so that is how all our original equipment manufacturers are depending on to our semiconductor industry. Okay, like SoC manufacturer. So coming to this SoC manufacturers, does this SoC manufacturer will do everything on their own? For example, Nvidia is there. Does Nvidia will do everything on their own? No, no. They need a fabrication unit through which they can fabricate their end product. Like what are the famous fabrication units we have? TSMC, UMC, or Samsung. So these are the fabrication units. And even these fabrication units, can they do everything on their own? No, they cannot do. They have to take support from EDA tools like Mentor, Synopsys, Cadence. All these guys are the one who are helping these fabrication units as well as our SoC manufacturers or FPGA manufacturers. So, and one more thing is like if you see the example of NVIDIA. So, does NVIDIA do everything on their own? No, they cannot do everything on their own. They need some support of IPs. Cadence is very well known for producing IPs like I2C is an IP, I3C is an IP, or AMBA protocols like AXI, APB, AHB, CHI. All these are what AMBA protocols. These are the IPs. So if at all a company wants to make its own IP, it takes a huge amount of time for them. Preparing an IP would take more than 6 to 8 months of time. Why should they waste their time on preparing an IP, which is basically used for communication between the devices? So what they will do? They will buy it from the vendor. For example, Intel or Nvidia will go to Cadence and they will ask like, I want an AXI VIP, do you have it readily available? They will say yes, it is readily available, and it is available for some 30 to 40 million USD. You just buy it, plug and play. So even this SoC manufacturer cannot do everything on their own. He depends on some other IP vendors. Okay, so this is how the ecosystem of semiconductor works. Like what we generally see is the end product. For example, you might be seeing Range Rover cars or some Lexus cars on the uh, uh, in the market. But how is this? How are they bringing that product into market? See, because uh, they need the help of some SoC manufacturers. These guys are again depending on some IP vendors and also some other fabrication units. Indeed, these two guys are again depending on some tool providers. So wherever you see the change of the wherever the transition is there, there is a requirement for VLSI engineers. Here there is a requirement, here there is a requirement, here there is a requirement, here there is a requirement. Everywhere there is a requirement for the VLSI guys. Okay. Yeah, this is a typical SOC on how SOC will look like. Okay, SOC stands for System on a Chip. The name itself is telling. What is it? It's a small chip. What is this? This is a small chip. But what it has on it? It has an entire system on it. Okay, if you see your mobile phone, and if at all you ever got to open it and see, SOC will be of this much size, and it has lot of tiny things onto it. Okay, lot of tiny things onto them. So what is this? And in contrary to this, if you see your laptop, what is the size of laptop and what is the size of the processor of the laptop? It is quite big, very huge. But the same thing, if it is an SOC, it is quite small. Means what are you doing onto an SOC? The name itself is telling you are trying to bring an entire system onto a small tiny chip. And what does it have? It has many things into it, like it has a DMA, it has many CPUs, it has GPU, it has Bluetooth, it has NFC, it has many IPs into this, it has some power unit. So all these things, and in real time world, on this single CPU alone, there will be 100 to 1000 people, 1000 people working on this, each and every individual CPU. Basically, what you are seeing is a quad core CPU here. Okay, so wherever you see one unit, that unit alone will require thousands of engineers to work on. And the ratio is that for every one design engineer, the ratio is that it requires at least 3 DV engineers. For every one design engineer, we need at least 3 DV engineers. And believe me, like India and China alone are producing more than 70% of world's DV engineers. So the basic question comes is, why not design engineers? We will answer to this question probably in due course of time. Okay. I don't know what happened. I'm not able to move the slide properly. Okay, fine. Okay, now let us see on what is the role of VLSI in our future. Okay. Okay, now it's fine. Okay. So see here, the future with respect to VLSI is quite promising. Because why do we say that it is promising? Because we have lot of innovations into this, which such as artificial intelligence and IoT, which these things are having huge demand. Why are they into huge demand? Because they use very less power and quite energy efficient. That is the reason the VLSI is quite more into the current trend or current market situations. And what is the scope of this design and verification? What is the scope? See, the design verification of the VLHS chips is quite critical in the process, because this is the one who is going to consume more than 70% of the time in your entire design cycle of the VLSI. Okay, and this is a phase where you are going to make sure that everything, all your functions, specifications is meeting perfectly, and your device is working properly, or it is functioning as per the requirements. And as we have discussed, like there are many stages involved into the design cycle of the VLSI, like what? Design, simulation, synthesis, physical design, and verification. Okay, verification. And what the other thing that comes into the picture is the testing of it. Okay, so with respect to the demand of AI and ML increasing day by day, as the demand increases, the it means that the demand for chips also is increasing. Why? How is this increasing? Because this AI and ML needs to be running on some hardware, right? Basically they are AML hardware chips. Nvidia is quite famous for producing machine learning chips nowadays. So the moment the growth demand for AML increases, the demand for AML chips increases. The moment the demand increases, the necessity or the demand for skilled engineers increases day by day even more. I think it is because of that annotation that I'm using. Okay, now see what is the potential of VLSI. See, the VLSI can be used across many applications. For example, AI accelerators, quantum computing, edge devices. It can be used across wide variety of things. For example, let us take an example of an AI accelerator. What is an AI accelerator? Can anyone give any basic example of an AI accelerator? Anyone basic example of an AI accelerator? Hmm? See, the best example you could give is a GPU, graphical processing unit. CPU is a normal one, okay, normal one, but GPU, it's an accelerator, AI accelerator. Even you might have seen somewhere in YouTube or in your Instagram shots or whatsoever, the Nvidia guys, Nvidia CEO is explaining the difference between a CPU and a GPU. Like, in order to what paint the picture of Mona Lisa, a CPU takes probably some hundreds of seconds of time, but whereas GPU, it will do that thing in fraction of a second, not even a single second. It will do that painting thing in fraction of a second. Means what is happening here? Means it is accelerating the work of a CPU into thousands of folds, right? So AI accelerators are more into demand nowadays, and the best example of AI accelerator is a GPU, whatever the GPU that you are using. Like, in fact, all your machine learning and deep learning things, they are all using AI accelerator. What does this AI accelerator will do? It will speed up the process. In fact, it will reduce the time taken to train your model. Basically, in machine learning, what you will do, you will train a model, right? You will take one model and you will train a model. For example, one example I could give you is, you know in India, many people are suffering with cataract, right? There are many people who are suffering with cataract. In olden days, what doctors used to do, they used to see the eye, and they used to do some kind of what diagnosis on that eye, and then at end they used to come to conclusion that this eye is having cataract and this eye is not having cataract. So the time taken was quite huge. But now what happened, they are simply putting one device in front of their eyes. They have taken one device, they are putting it in front of their eyes, and they are specifically telling like whether that particular eye is having cataract or not. How does this rapid change happen over a period of time? Initially, what happened is, all the vendors, or the companies like Google or many other data processing companies came into all these local eye clinics. Whatever the eye clinics that were there in India, they came to us, and they have collected the data from the doctors. They have sat with the doctors, and they were asking like, in this, which is the eye that is having cataract and which is the eye that is not having the cataract. So what they have done, they have collected tons of data. They have collected tons of data, and they have trained their model. They have trained their AI model with respect to the data that they already have. Okay, like, the moment they, I mean, if at all you want to train a model, what you need many number of data sets, right? The moment you want to train AI model, what it requires is, you want huge number of data sets. More the number of data sets, more will be the accuracy. So they got this data set. Okay, they have taken these data sets, and they fed this data to a AML machine. So this AML machine was continuously taking the data, and it reached perfection. Now what they have done, they went back to the same clinics, and they were telling like, we have prepared a model, or we have prepared one equipment which can detect whether your eye is having cataract or not. And if at all you want to buy it, please pay 1 crore, or we are giving it to you at a discounted price of 50 lakhs. For this, you need not to do anything. We just project our device in front of patient's eye, and it will automatically tell you whether that eye is having cataract or not. Basically, they have taken the data from the doctor. They have trained a model by using the data, and they are selling a device back to the doctor with very high price. So how does this thing happen? It happened because of VLSI, because you are able to train a AI model very quickly. How come you trained your model so quickly? It is because of AI accelerator. Okay. Or if at all you are not able to imagine what I have told you, assume that you have taken a cat and you have taken a lion. If you see, cat and lion both will be having similar features, right? They have similar features. And if at all I give a image of cat to a AML model, so it might be misinterpreting this cat as a lion, or it might be misinterpreting the image of a lion to be cat. So in order to distinguish it properly, what we have to do, we have to feed this machine with lot of images of cat and lot of images of lion, so that this device will get trained like anything. The moment it get trained, you give the cat image, it will outrightly will say whether it's a cat or a lion. Same thing here also. The moment you train your AI model with huge number of data sets, it is clearly able to distinguish whether the particular eye is having cataract or not. So how all this thing came into the picture or happened? It's because of simple AI accelerator. Okay. And all these AI accelerators are purely coming to the picture because of our very large scale integration, that is VLSI. Or even, the Google CEO was Sundar Pichai was talking about tensor processing units. Yeah, all these TPUs are purely out of VLSI. All your VPUs, like, vision processing units, which are basically used into your computer vision, they are also the products of VLSI. And these things can do the computations like anything. Okay, in nanoseconds they will do computations. Okay. Yeah, that's what we have seen, right? About AI accelerators. There are basically two kinds of AI accelerators, that is the data center and edge center. So what does this edge center will do is, it is out of the scope of VLSA, but still, it will do some kind of analysis at the end product. Instead of doing it in the direct client server, what it will do is it will do the thing at the end servers. Thereby, you can save some time actually with respect to this edge AI systems. Okay. So, like, yeah, and actually these things are out of the scope of our current discussion. Now you see, like, where VLSA can be used, all the features of ADAS, yeah, advanced driver assistance system, basically all these things are purely because of chips or ICs that were made out of VLSI technology. Whatever the feature that you see, like, the collision detection system, or the lane detection system, or automatic speed detection system, what all the things that you see in an automated car are purely the products of VLSI. Okay. And all this healthcare system. So like, what are the different opportunities into VLSI industry? Like, these are all the companies that were offering what quite good feature, or these are all the quite famous companies that will give you very good career opportunities to you to be getting into this VLSI industry. Okay. And I myself have opportunity to work with NXP, Intel. Where is Intel here? Intel and AMD. So there are, few companies. And okay, like, okay, so how is the scope of semiconductor industry in India? What is the scope? See, it is expected that by 2029 semiconductor industry will be growing at 1.21 trillions. Okay, 1.21 trillions. And Indian government is very keenly observing the semiconductor industry, and they want to bring semiconductor fab into India, and they are working like anything to do that. And Indian government has already taken very good initiatives into this, like, they have planning some semiconductor unit into Gujarat. Like, there will be two units they are planning, and they are also planning one more unit in Assam. So basically the fabrication unit is the need of the hour for India. Okay. So the moment fab comes, the demand currently India is very well known for its DV engineers, design verification engineers. The moment fab comes to India, then the demand for design engineers will also grow like anything. It will grow like anything, and it is going to happen in near future. It means that there is quite huge demand for VLSI guys in India. And in the next 3 to 4 years, the demand will be like anything. You will be seeing lot of people registering their companies into VLSI domain, because the requirement for VLSI engineers is going to be quite huge. Mm, okay. Are you guys able to see whatever the thing I have written here?
Yes, Prithvi, we can see it. We can,
But
but you're trying to
actually,
erase it, and
yeah,
yeah.
I'm not able to erase this. I don't know why. Okay, see here the future for semiconductor industries. See, the government of India are, as per our many of the newspaper articles, the expectation is that Indian semiconductor industry is to see a shortage of more than 3 lakh professionals by 2027. Okay, see what they are telling. They are telling that there is a shortage, there is a void, there is an empty space of more than 3 lakh engineers. The Indian semiconductor industry alone requires more than 3 lakh engineers. It is not me who is telling. These are the statistics that were given by leading newspapers. Okay, so there is a huge demand by 2027. Means do see, by 2027 they are telling like India is lacking or it is falling short of 3 lakh engineers. What does it mean? It means that, see, whoever the guys, for example, assume that there are around 500 people who are joined here. Okay, in this webinar currently approximately 500 people have joined, and by 2027 there are many people who will be graduating, right? Assume that there are approximately more than 2 lakh people who are graduating by 2027. It's a rough figure. So the government or the statistics have already taken these 2 lakh people into consideration, and they already assume that these 2 lakh people have already got placed into VLS industry. Even after assuming that, even after assuming that, the statistics is that India is lacking more than 3 lakh professionals in semiconductor industry. So it's a huge space for you guys to get into the industry right now. Okay, it's quite a huge for you. It's a great opportunity for you. Okay, and even Indian government is encouraging this semiconductor industry like anything. As you can see here, they are giving incentives for semiconductors in startups like anything. They have recently given 76,000 crores of incentive to semiconductor industry. It is quite huge actually. Okay, so this is an excellent opportunity for whosoever here to be a professional in near future. It's not just that I want you to convince to get into this. It is the statistics the people were talking about, right? And not just that, in maybe in the coming next 5 to 10 years, currently if you see in India, there are hardly I would say less than 300 semiconductor industries or less than 300 semiconductor companies that were registered. But in 5 to 10 years, this 300 would definitely become 30,000. Okay, it will be multiplied by more than 100 times. And in among these 500 people who ever joined here, at least, whether I don't know whether you believe me or not, at least 50 of you will be having your own startups by 2040. That is for sure, because that is the scope that industry is giving to you. You need not to believe me, you just go and google it, or I have presented the factual information for you here. So what you guys need to do, you should be industry ready. How can you be industry ready? Yeah. Okay, these things we have already discussed yesterday, like what are the different roles you can work on to. Okay, I'm not going to go through this deep into this. Like, so let us see this. Like, how to be industry ready. First, what you need is you need to be industry ready. You need to be a trained professional. Okay, in near future, like maybe in next 3 years, after 3 years, the situation will be that the moment you say like I know Verilog, I know system Verilog, you will be hired just like that, because the demand will be like that. In fact, the demand is becoming like that for a 3+ years of guy. Currently, the market is that if at all you have 3+ years of experience, the interview is nothing. You tell some nonsense in the interview, they are hiring you, because the demand is like that. And but currently the demand is for 3+ years, but in the next 3 years it will be huge. Even though you're a fresher, the moment you say some basics of Verilog digital and SV, with whatever is your performance, they need guys, they need manpower, they need more than 3 lakh engineers guys, so they will hire you like anything. The hiring is going to be phenomenal. But if at all you want to be part of this ecosystem, what are the things that you need at your end? So how can you be industry ready? How can you make sure that you are about to enter into the industry? The first thing you need for that is, as we have seen yesterday, right? We have seen an example of a full adder. So in the design of the full adder, what did we do? Initially, we have taken one XOR gate and one AND gate, and we did something. So all these concepts of XOR gate, AND gate, all these things comes in what subject in our academics, which is the subject that focuses on these things? It is digital electronics, right? It is digital electronics. So first and foremost thing, if at all you want to be industry ready or you want to be part of semiconductor ecosystem, is that you should have strong knowledge in digital design. Okay. Okay, you are good at digital, then what next? So what did we do after this digital designing? Hmm? What did we do after this digital designing? We have used an HDL, right? We have used an HDL in order to describe this hardware by using one language, that is HDL, hardware description language. By using some language, I have described the hardware, like how many XOR gates I want, how many AND gates I want, how many NAND gates I want, how many NOT gates I want. So all such things I have done by using a language, which is basically describing a hardware. So what is that? That is a Verilog language or VHDL or whatsoever. Apart from this, what I need? So I have, okay, so initially we have designed it, designed a hardware, then we have written a code for it, then our design is ready. Now after that, what did we do? We have to verify it, right? So in for verification also you need some language. What is that? That's a HVL. HVL is nothing but hardware verification language. So you should be having some knowledge on HVL. What is that HVL? That is system Verilog. System Verilog alone is not enough for you to be industry ready. You need something else apart from system Verilog, that is UVM. UVM is not a language, it's a methodology. Basically, there are many methodologies, but UVM is quite famous. Like, there are other methodologies like open verification methodology, OVM. UVM stands for universal verification methodology, but UVM is quite famous. And even in earlier days, there are some specmancy system, many other things were there, but they are outdated. And currently, the trending one or the one that is in huge demand is UVM. So, what is the first step in order to be industry ready? You should be good with digital design, and the second thing is you should be good with your HDLs, that is Verilog. Then you should be good with verification of your designs, that is HVL. What is the HVL language? System Verilog. After that, you should be having good knowledge on what? UVM. Is this alone enough? No, this alone is not enough. Apart from this, what you should be having is you should be having some strong debugging skills, and also you should be good at analytical ability. You should be having very good knowledge on analyzing the things, and you should be having good knowledge on debugging those errors or error scenarios or whatsoever. Okay, so assume that you know digital electronics and you are also familiar with Verilog, system Verilog or UVM or whatsoever. Okay, and you also have a very good knowledge on debugging. What else? What next? What next is you should be having very good hands-on experience onto your industry tools. What are the industrial tools? Like, Vestasim, Xilinx, Vivado, or whatsoever the things that are available into the industry. You should be having a hands-on experience onto these tools. Like, you should be at least used this any one of these tools at least once or twice uh, in your career so far. Okay, okay. Then assume that you have even worked on to any one of these industry tools. What else? What next is required? What next is required is you should have any knowledge on any one of the protocol. Like, what is a protocol? Why protocol? How come a protocol can be used into the VLS industry? All these things we will be going to discuss tomorrow. Okay. Actually, basically, tomorrow, please don't miss tomorrow's session, because tomorrow is the day on which I'm going to start coding for you guys. Like, I will be showing you how to describe a hardware using Verilog. I told you, right? Like, by using HDL, we are describing a hardware. How are we exactly going to do that? That's what we'll be seeing tomorrow. Okay, tomorrow I will show you on how to use the free EDA tools that were available in the open source. I will show you how to access them, how to use them, and basically we will be executing few codes also tomorrow. If not tomorrow, probably day after tomorrow. Okay, if time permits, we'll be doing that outrightly tomorrow. So I will be showing you. We will be tomorrow. We will be writing Verilog coding. Okay, we will see that tomorrow. And also on the next subsequent days we'll be discussing what is a protocol, how is a protocol works, what is the practical significance of a protocol. All these things we'll be discussing in our due course of time. But in order to be industry ready, what you want is you should be having a good knowledge on protocols, like PCIe. I myself have very good knowledge on PCIe, and currently it is in huge demand, PCIe and DDR. Okay, DDR, these two things are in huge demand currently into the industry. uh, or USB, Ethernet, all your AMBA protocols like AXI, AHB, APB, SPI, I2C, UART. So you should be having some basic knowledge on these protocols. any one protocol. Okay, the basic protocol everyone should focus at the start of their career is the APB. It is quite a basic one, and its spec is not more than 60 to 80 pages. But if you take PCIe, its spec is more than 10,000 pages. The spec alone is more than 10,000 pages. Okay, so don't choose something which is hard for you. So it is good to start with something easy to learn. Okay, once you are done with the protocols and you have the knowledge of protocols, then it is advised, it is actually optional in order to be for a fresher, but it is always a good thing to know any one of the scripting languages like Python, Perl, or Tcl. Okay, so this is how you can be industry ready, guys. Okay, I repeat again, what is the first thing you need? Digital design. Once you are done with the design, what you have to do? You should know any one language, like any one hardware description language like Verilog, and then you should know any one verification language like System Verilog. Then you should be good with UVM. Once you are done with that, you should be good at debugging skills, and also you should be having some knowledge over the tools like QuestaSync, Xilinx ISC, or Vivado, or whatsoever the tool. You should be having a hands-on these tools, and you should be having very good knowledge on any one of these protocols like PCIe, USB, Ethernet, AMBA, HB, APB, I2C, I3C, or whatsoever. Okay, once you are done with this also, then what comes is the scripting language. So we here at HIEE will make sure that you are industry ready. Okay, I am here to help you guys to be industry ready. Okay, I will make sure that you will be learning all the things with respect to digital, and you will be learning Verilog, System Verilog, and all these verification methodologies. And I will be making sure that you will be working on these protocols, any one of these protocols, and I will try to give as much knowledge as possible depending upon the way that you grab the things. And optionally, this scripting also. So we at HIEE will be focusing on to make you industry ready. Okay, isn't it exciting, guys? Getting into industry and learning all these things, focusing on, yeah. Okay, so tomorrow, please don't miss tomorrow's session. And tomorrow we will be seeing on basics of Verilog. So whatever we have discussed today and yesterday is quite, it's like introduction, or the basics of what is VLSI all about, or how can we be industry ready, or what we need to do in order to get into the industry, what basically VLSI is all about, and how it differs from embedded systems. All these things we have seen basically, right? And tomorrow onwards we are going to see the coding. Yeah, tomorrow we will see the coding of Verilog, and I will show you tomorrow on how different tools can be used and how you can access them for free. All those things we'll be discussing tomorrow. Okay, yeah. So with this I would like to conclude today's session, and now we are open to doubts. Okay.
Thanks, Prithvi. Before we start on with the interaction on the doubts, clarification, and all,
Mm-hmm.
I had many questions regarding the training as well as the certificate that you're going to receive, guys. First and foremost, regarding the certificate, please give your feedbacks. We will look into your respective attendance on it, and the maximum that you have to attend is at least 3 out of 5 to get a certificate. Okay, if you have missed yesterday's session, please don't worry. It is available on our YouTube page. The content is for you guys. We request all of you to attend and visit our yesterday's session recording on the YouTube channel that has been mentioned on the chat box already. And all the people who are on YouTube, you can also check that your feedback link is being shared. Please have a look and let me know if you are able to access it or not. And the second point is regarding the batch and the course fee. Most of you have questioned on that. There is a batch that is going to start on January 20th, 2025. And our team has put the respective links to get registered. And if you want to get in contact with us, we have provided our numbers on the chat box. You can contact us at any moment of time. You can visit our website also, www.hiw.in. Okay. Coming to the tomorrow's session, most of you have asked a question asking if tomorrow is a holiday, do we have a session? Yes, guys, this is a continuous 5-day session. Tomorrow also at 7 p.m. we will have a session. You can all connect on session, guys. Coming to presentations, we will get back to you on the presentations, guys. We have to discuss and then get back to you, and we will give you the information regarding the presentations in tomorrow's session. Thank you for it. What will be the offline training location? It will be Hyderabad, Aman. Yes, the session is open for discussion on technical queries, guys. Guys, we have posted our feedback. Our team is actually posting our feedback links as well as the other segments. Before we go on with that, I had a question. There was a lady who asked the okay, before we go with, Swarali asked, sir, for triply, should we choose VLSI or embedded?
See,
Prithvi,
yeah, see, basically, if at all you are a guy who is interested in integrating the things, and who, if at all you are interested in system level things, or if at all you are interested in product development, then embedded systems is the future for you. If not, see what is there in an embedded systems. If you go deep dive into that, there exists VLSI. There is a processor. Around the processor, you are connecting something and making it to work as an embedded systems. So you decide on which level you want to work. More the core level you work, more will be the salary you will be getting. And less the core level you are working means embedded systems is less of a core, I would say. I mean, it is also a core, but if you strictly speak, see, if at all you are designing a processor, it is something amazing, and you are using a processor, there is a difference, right? Who will be what valued more? The one who designs it or the one who uses it? The one who designs it, right? The creator. So VLSI guy is a creator here. Embedded guy is the one who uses this for his specific application. He will be taking this processor, embedding it into something, and he will be using it for his own application. So who is valued more? Obviously the designer. And but the thing is, VLSI is quite difficult here. Oh, no, I mean, it is difficult. That is the reason it is getting paid high. Only the intellectuals or the intelligent people will be sustaining in VLSI industry. Okay, so, like if at all, in order to specifically answer to your question, it is up to you on where you want to be. But as a VLSI guy, I would suggest you to be part of VLSI ecosystem, to be part of semiconductor ecosystem, because it is quite fascinating and it is challenging every day, and it pays you more. At the end of the day, what is important for us? How much ghee we have in our plate, right? So VLSI industry will give you that. Okay, it will give you money like anything. With the money, you will feel like you will buy half of the Hyderabad. Okay.
right. There's a question from Harshad Kulkarni. I asked about how will new fabs in India affect job roles in future? Will PDDFT engineers will be in more demand than DV engineers?
No, see, if you see 100 engineers working on a project, among those 100 engineers, there will be more than 60 engineers who are specifically working on DV, design verification. Rest 40 is divided in PD and design, because design verification is something which has huge scope, and that is where many things can go wrong, and that is where many people are required. Okay, and obviously, with respect to the current demand for PD engineers will grow. That is for sure. Because if a fab comes into India, no, the requirement for design engineers will also grow like anything. But fab is something that cannot be constructed overnight, over a year. It takes time. Constructing a fab is not a joke, yeah. The best example I could give you is: have you ever entered an ICU? ICU is, I guess, class 10 or class 11 grade. But if it is semiconductor fab, it is class 1. Means, uh, uh, I don't know whether you know about these classes or not, but it is quite difficult to maintain the fab, and it will take at least 10 years to build fab in India if you start right today. So gradually it will come. It will come. But it takes time for PD engineers to get into much demand as like a DV engineer. Okay. But the demand will grow eventually.
Okay,
Yeah.
there's a question from Karthik Reba asking VLSI industry has more ladies than gents. Do we get
Uh,
the true or what is the question?
I don't know. Yeah.
Okay, there's a question
See,
from Rishi. Okay, sorry, you want to answer it? Yeah.
it's okay. It's okay. No problem.
Right. There's a question from Rishi, ma'am, for joining VLSI, which institute is we have to join better. We will obviously say it's HIW Rishi.
See, for this question, I would say I'm a guy who graduated from NIT Delhi. Yeah. Okay. And I hope this alone would justify you whether will I be, training you in a proper way or not. Okay. and I have my own dedicated team who are from who have done PhDs and who worked on various projects, and who have, like, 8 plus 10 plus 12 plus years of experience, and quite good team, technical team I had with me, along with me. So they will be coming and teaching you things like anything. So with your question, we would obviously say it is our institute, that is HIEE.
Thanks, Rishi, for the question. There's a question from Aman Gupta. According to you, what would you be more preferable to opt DV or PD? As PD will take a lot of time, around 10 years or something. Prithvi, before you answer this question, guys, most of you asked about the price of the course. Please do contact our team personally to get to know more information about the course and all those. We can't disclose the course fee and all on this respective, as it is purely dedicated to discuss technically and understand on VLSI, guys. Thank you so much for your question on course and interest in it. So, Prithvi, I'll repeat the question for you for Aman. Should I?
Yeah, please.
According to you, what would be more preferable to opt, DV or PD? As PD will take lot of time, around 10 years or something.
See, it's not like PD currently do not have openings. Even PD have openings right now. Okay, but the ratio is less. And compared with DV and PD is slightly difficult. I feel it difficult because I myself have published few papers on PD. On CMOS. So compare it with DV, PD is slightly difficult. It is not too difficult. It is slightly difficult. But openings, and with respect to the ratio of a DV engineer to a PD engineer, DV engineers are more. Okay, for every 3 DV engineers, there will be one design engineer and there will be one PD engineer. So you choose accordingly. And moreover that, it is your interest here. Whether you are a guy who want to do the coding, or you are a guy who want to work at a circuit level, like how does a CMOS works, or if at all you are interested into that, you can choose PD. No, I'm good at coding, I can do coding like anything, I have good knowledge on hardware, then you can come to DV. But to specifically answer your question, DV guys have more scope. You if at all you pursue DV, it is easy for you to get into industry because openings are more.
Okay, there's a question from Nitin. What is the role of AI and ML in VLSI design? Nitin, we have answered this question in yesterday's session. You please have a look on to the yesterday's recording. The question from Mohan Kumar, which state or region in India is best for VLSI? Can you please tell us about the role of government? I think the last third slide was something that we discussed about the role of government and how the Indian government is taking some steps to make it VLSI into coming years, Mohan. And Prithvi would like to add something on this.
Yeah, see, basically, as Bhavya told you, Indian government is giving 76,000 crores of incentives. Okay, even if you want to have a startup, you can take benefit out of it. And it is in with respect to your question, like, the fabs are going to start getting started in Gujarat, and I think in Arunachal Pradesh or somewhere in northeast. But currently, semiconductor industry in India is concentrated in 3 areas. One is Greater Noida, that is Delhi. Other one is Hyderabad, and other one is Bangalore. So these are the 3 areas where semiconductor industry is highly concentrated. Yeah.
Okay, there's a question from somebody. If I have to enter into VLSI, should I do my master's in VLSI?
Not necessarily. Do you think every engineer is having masters in VLS industry? No. I have told yesterday, even guys from diploma were into industry. Okay.
Okay, Bhavna, we are located at SR Nagar, Amirpet in Hyderabad. You can contact us, and the Google shows us the right location. You can come down or reach us anytime. Tomorrow we are closed. You can reach us by the day after tomorrow if you want to visit us. Which state or region in India is best for VLSI? Can you please tell us about the role of states? Question
Role
from.
of states. See, yeah, as I told you, currently semiconductor industry is concentrated in India in 3 states only: Greater Noida, Hyderabad, and Bangalore. As I am from Bangalore, I would obviously say, as I am from Hyderabad, I would obviously say Hyderabad. Yeah.
Right. Trupti, if you miss the first this batch, you will also have a next batch. Sooner, mostly in next coming 2 months, we might start on a second batch. So you can join us that so. Can we get a job in VLSI industry without taking any training in institutes and learn from NPTEL?
Yeah, it is possible, yeah. You can do that. But I don't see any courses of System Verilog and UVM on NPTEL. As far as I could see, only Verilog is available, I guess. But I feel that is quite not sufficient. But if at all you are intelligent enough and you know the
You can explore
what,
it by yourself. You can,
yeah.
of course, do that. Yes. Any questions, guys? I think we have addressed all of your questions, and the link is being shared. There's a question from Namit Patel regarding the coding in embedded. Difficult it would be to migrate from a typical Python or traditional programming language to an VHDL supporting program language?
See, Python and VHDL are nowhere related here. As I have told you, all the languages versus HDL. What is the difference? Your Verilog or VHDL are the only languages that are existing which can be synthesized. All your traditional languages, they cannot be synthesized. Okay.
Okay. There's a question from Harshad Kulkarni. Could you please highlight about DFT role and its potential or scope?
Yeah, DFT currently, I could see DFT is gaining popularity. DFT stands for Design for Testability. Actually, it is difficult to test a chip after the manufacturing. So what we guys generally will do is we will insert some scan chains into the chip even before the fabrication. Means even before the what the chip is, I mean the process is being sent to a PD guy. What we do is we do something known as DFT. There we use JTAG and we used to have some scan chains around the chip in order to make sure that the testing will become easy at the end. So even DFT is having good openings, but compared with PD and design, DFT's role is somewhat limited. Okay. And if you specifically ask with respect to DV DFT, obviously the DV is more. In fact, in current trend, no, DFT is being merged into DV. Now people are asking for guys who know DV DFT, not specifically DFT. It is DV DFT. The term is gradually changing.
Okay. There's a question from Parimala asking, is there any software for HDL that I can learn HDL on mobile, not on PC? Please reply me, sir.
On mobile.
Yeah.
See, EDA playground is one. That's what we are going to discuss tomorrow. So please attend tomorrow's session. I'll tell you on how you can do that. Yeah.
Thanks, Parmala, for question. We have question from Venkat Ramareddy. I have a lot of experience in teaching in Tripoli, but is it suitable for me to switch to VLSI?
Obviously, why not?
Okay. There's a question from Indrakhanti Kaveri. I'm from Tripoli background. Can I start VLSI training and is it suitable? Yes, it is of course suitable. You can attend. I heard somewhere that analog layout is getting automated. Is it true? If it is true, is getting a job as an analog layout engineer difficult?
See,
Question from Chandralekha.
see, Chandralekha, uh, automation comes in every industry, but it doesn't mean that it will take you out. With respect to PD, even though automation is coming to the picture, it is difficult to remove a PD guy. It is not possible because see, as I have told you, if automation is coming to the picture, what does that automation will do? It will only solve a known issue. Even if you see chat GPT, what will it do? It will run its database and it will fetch you some answer from existing one. If you ask it something out of the bound, it cannot do anything. It is you who have to think on your own. Same thing with respect to PD. The issues that you are going to run are quite dynamic in nature. So automation is possible to some extent, but not completely. See, VLSA industry is highly immune here, highly immune to automation.
Thanks, Chandralekha, for your question. There's a question from Vignesh. Is physical design course from NPTEL helpful?
I'm not sure on physical design here. Basically, I'm a front end guy, so you can ask me more about DV. But see, NPTEL is highly valued course. I just don't want to exaggerate about myself and do all these things. But as a matter of fact, NPTEL courses are always good and they're quite knowledgeable. Probably what I would say is you can go through. Yeah.
Okay, there's a question from pursuing candidate Shraddha. Yes, you can start your career in VLSI, Shraddha. Okay, guys who are pursuing, you can take the course on VLSI with us, no problem at all. okay, you can enter into VLSI field also, and you might get an opportunity to work as an intern. Okay, there's a question from Nitin. How do you implement power gating in a circuit?
See, these things are, of high level things. I cannot discuss them over here, and that falls beyond the scope of the discussion.
Nitin, you please get back to us. We'll answer your question in person. Thank you. Pallavi's question is, can you teach cadence?
See, Cadence is the name of the company. What you want in Cadence? Cadence Virtuoso or Cadence Exilium? What you want?
Okay. There's a question from Om. Can you give more insights about DFT and its potential?
Yeah, that's what I've told you. DFT is something that can
Going
be
to talk
used.
about it in the next coming sessions also.
Yeah.
Yeah. Mm, Then there's a question from most of the pursuing candidates. Yes, you can get our course and get trained on this, no problem at all. There's a question from Roshan. HDL Bits website I am using for having practice in Verilog. Is it good?
Yeah, it is good, yeah.
It's question from YouTube. Um, Sir, would you give guidelines to enter? Yes, I think all the pursuing candidates we have answered. Our timings of the course would be in the morning, guys, from 7:30 to 9:30 till 10 o'clock maximum, both theory and practical included in it. Lakshmi says she wants some VLSI projects. Where can I find and do the projects? Prithvi, would like to answer this
Yeah,
question.
sorry, come again.
Uh, she wants some VLSI projects in her resume to be put. Where
Yeah,
can
okay, we can help you with that. See, it is not a software thing. No, if it is software thing, if you scroll across, you might get something because VLSA industry is not like that. It is highly dynamic, and you will not be finding them online. So we will help you with that. We can help you with that, even with respect to your academic projects or your final year projects also. I'm planning something, some platform for that also. So we can help you with that. HAW can help you. Yeah.
Lakshmi, you can contact us. There's a question from Srihari. I think STA roles can be replaced by AI.
STA.
Yeah, STA.
Yeah, static timing analysis. See, the question to everything is same here. It is possible in everywhere automation is possible, but not completely. Okay, and the moment I say you say STA, you're going into PD, physical design, and physical design even DV can be automated to some extent, but PD no chance. It is difficult. It is not that no chance. It is difficult. Okay.
Right. There's a question from Vijendra Kisara. Ma'am, from the final year of ECE, can we be placed in VLSI industry as soon as possible by acquiring deep knowledge in VLSI? Yes, it is possible. It purely depends on your exploration also. Somebody, Shraddha's ma'am guidelines to start. This is the guidelines that we're trying to give you, Shraddha. Please follow up masterclass and then you can do join our course to get more detailed information on the VLSI to get into the industry. What are the company requirements to hire me after BTech as a fresher? Badrinath, we will answer your question in coming sessions. Thank you for the question.
But we have already answered that question, right? Like how to be
Yes,
industry ready.
I think every day we're gonna answer this question. What is the requirement?
Okay.
So I just wanted to confirm that so that he can join tomorrow to understand it more. Okay, I face problem in designing analog circuits. I prefer it is because it's cheaper than digital circuits. Which course can help me in designing new devices? Question from Abdul Alim.
Can you repeat that?
One second. I face problem in designing analog circuits. I prefer it because it's cheaper than digital circuits. Which course or training can help me in designing new devices?
See,
Uh, Maybe
so you
analog
should.
circuit in maybe he's talking about embedded, I feel.
Mm-hmm. Okay, probably. Or if it is with respect to VLSI, you're talking. If at all you're interested at circuit level, what you have to do is physical design is best for you. Yeah.
Yes, we do offer internships on VLSI at HIW. You can register with us. So, um, not necessary that you should do your higher design. I mean, like higher education to pursue your VLSI, guys. Um, Thank you all for your queries. I think we can stop it here for the moment. Yeah. Yes, I think we have answered all the questions. Just give me I'll have a look on to YouTube. And yes, almost all of them have other questions have been answered. Which tool is used in the industry to level for backend? Question from Shanti Kumar.
We can see that tomorrow. Yeah, I will explain you on what are the tools and how you can use them. All those things we can
Oh,
see tomorrow.
great.
Yeah.
Thank you guys. Thank you so much for your patience, and your queries were good, and it was encouraging for us to address you all. And please give your feedback. The link has been shared on the group. We will also share our internship details sooner. Please do follow our Instagram, LinkedIn, and all other handles so that you can get into the information according to our new batches that will be announced soon. Thank you so much. Have a good day. Good night, guys. Thank you,
Yeah.
Prithvi, for your patience.
Thanks, Bhavya. Thanks, everyone. See you tomorrow. Bye.
Guys, regarding PPT, we will surely let you know by tomorrow. Thank you for the information.